Okay. Couple disclaimers before we get started. 4.2 is about graphing sine and cosine, and it's going to take us a couple of class periods to get through it. I teach this in a way that's a little bit different from how the book does it. I don't know that I've ever seen another teacher do this exactly the same way, but it seems to work pretty well for my students. I got to tell you something though. I am going to, not purposely, but I'm going to mislead you a little bit today. Okay, I'm not going to lie to you, but I may hide some like details that we don't need yet. Okay. So you know how we do that in math. We do it all the time, right? We tell Algebra 1 students you can't take the square root of a negative number. And then Algebra 2, we're like, actually you can, right? And it's not because we're trying to be mean and like hide things from you. It's just like we don't need to deal with that when we're in Algebra 1. Let's just like save it for later. So there are a couple details that we're going to save for later. Okay? Now some of you may, if you've seen this stuff before, you're going to recognize like what I'm talking about once we get into this. I'm just telling you this in case. I know some of you work with some tutors, or you might have some friends in some other classes. If you're working on this stuff like over the weekend and you're working with the tutor and your tutor's like, well, actually, that's not true. Like, that's cool. Just don't know that I'm not trying to lie to you. We're going to get to that part on Wednesday next week, okay? You get what I'm saying? All right, so let's do this. It's going to be awesome. You guys are going to do great. This is really important for us. We're going to learn how to graph these functions by hand. Guys, I need you to stop, okay? If you can't, then separate yourselves. This is really important because trigonometric functions come up a ton in applications. There's so many things that follow a sine or a cosine curve, natural things to when you're building structures or designing circuits, or there's just so many applications of this stuff. The reason we learn how to graph them by hand is so we understand what these things look like. So when we do come upon an application, we can sort of visualize what's going on. So we're not doing this just because, like, as an exercise in can you look at an equation and get it down on the paper. Our graphing calculator can do that for us. But if we understand what these things look like and how the points relate to the function, that's going to help us out when we get to some applications. And next week we're going to be creating some functions to predict like the number of hours of daylight in Ferndale on graduation day this year and that kind of stuff. So, so it's really important that we get to this. And again, I'm going to show you sort of my take on this, which might be a little bit different from some others. So let me give you some vocabulary and symbology here. This is a trigonometric function. We have a number out in front here, this -2, and the 2 portion of it, disregarding the negative, is something called the amplitude. And a lot of times we'll use an A to represent amplitude. And amplitude shows up on a graph here. The amplitude is the distance from what we call the center line of our graph to the max, and it's actually the same down here as well. So this would be our amplitude, and this would also be our amplitude. All right. We got our trig function there. We're going to focus on just sine and cosine for right now. Inside of the trig function, typically you're going to have an x, and x will have a coefficient. And this coefficient is the Greek letter omega. This is not a W. It's kind of a rounded W, and that is pronounced omega. And I want you using that word for it. It's going to look weird to see a W and say omega, but you'll get used to it. Omega is related to the angular velocity. I heard someone say that a minute ago. Omega does not show up on our graph, but omega is related to the period, which is t. So t is the period. And the period is the horizontal width of our graph, of one pattern of our graph. So that would be t. Omega and period are related by the following formulas. Omega is equal to 2 pi times the reciprocal of t, and period is equal to 2 pi times the reciprocal of omega. And it's really convenient that those are basically the same formula. You're just flip-flopping the variables. You don't have to worry about two different. Now, the reason I do reciprocal instead of, there's another formula that says omega equals 2 pi over t, which is probably what your textbook says, and that t equals 2 pi over omega. I think about it as a reciprocal because oftentimes one of them is a fraction, and we don't want fractions inside of fractions. Thank you. So we'll do some examples here. I just want to practice translating between these two things because this is going to be every single problem we're going to do today. We're going to have to translate between omega and t. So if I were to tell you that t is 10, then using our formula here, omega would be 2 pi times, what's the reciprocal of 10? 2 pi times 1/10, or 2 pi over 10. But we would, of course, simplify that. What would it be? We wouldn't write 2 pi over 10. We'd write pi over 5. So if t is 10, then omega is pi over 5. If our period is 3, let's do the same thing. So 2 pi times the reciprocal of 3, 2 pi times 1 over 3, that's 2 pi over 3. All right, going from omega to period, this is where it's often useful to use the reciprocal. So we're going to find t. T is 2 pi times the reciprocal of omega. What's the reciprocal of 5 pi over 6? 6 over 5 pi. The pi's cancel out. I got 2 times 6 over 5. That's 12/5. All right, omega is 8 pi, so what's t? Well, it's 2 pi times the reciprocal of 8 pi, 1 over 8 pi. And again, your pi's cancel. That's 2 over 8. But we wouldn't write 2 over 8. We're going to write 1/4. All right, what questions do we have at this point? How many people have seen period and omega before? Has anybody, you guys have done, did you guys graph these in Algebra 2 last year? Oh, you learned them in physics? Okay, cool. And they use omega also? Cool, that's great. All right, well, you'll have to tell me how different this is from how you learned it last year. Okay, all right, this next part is kind of the part that I'm like hiding some information from you, okay? Just so this is the part that we're going to expand on next time, but that's okay. If I can kind of get you to just trust me on this, I'm not lying to you on this, but I want to show you what a single period of sine and cosine, both the positive and the negative version, look like, okay? And we want to, and the reason we're doing this, if I can get you guys to sort of internalize the shapes of these four things, these are going to be the building blocks of everything we're going to do with section 4.4. Okay, so this is really the key information here. But not 100% of it. I'll give you the rest next Wednesday. So here's what I need you to get down. I need you to know some particular important points and then the shape. So positive sine is going to have this point here at our anchor, and then one here, 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 and here. And when we connect these, we're going to do it with a nice, smooth, swooping curve. It is not a triangular, jagged curve. It's a nice, smooth curve. That is what a positive sine period looks like. Okay. And then a negative sine period, well, it's just flipped upside down, right? We're used to transformations. It reflects it over the x-axis. And so it would look like this. So that's what a negative sine period looks like. All right, positive cosine period has some different points. Our key points are these ones. And again, make sure you're giving a nice smooth curve. And a negative cosine is that thing just flipped on its head. Many of my students in the past have commented that a sine period kind of looks like an S on its side, and a cosine period kind of looks like a C on its side. And that's helped them remember which one's which. Now, I've left this star here on each of these, and this star is going to be our anchor point for what we're doing today. Okay, that anchor point is always going to be the origin. So this point right here, so cosine does not go through the origin, and sine does go through the origin. That's our origin. That's 0, 0. So when we're looking at this, this line down the middle, this center line is going to end up being our x-axis for today. Now, we are eventually going to start shifting these things around, so that's not always going to be the case. So our anchor point won't always be at the origin, but for today we're not doing any translations, any shifts up or down, left or right. Okay? So here's what we're going to do. We're going to graph our first sine function. You guys ready? It's going to be awesome. All right. Now, I didn't give you an equation here, but I've drawn sort of the framework, and I want you to fit a positive sign into this framework. So what I really need you again to internalize is that a positive sign has that point at the anchor, and from there it goes up and then back to the center and then down and then back to the center. So go ahead and draw those points on there. So starts at the center, then it goes up and then back down across the center to the bottom and back over. And then connect those points with a nice smooth curve. All right. So we've drawn one period, but here's the thing. These things are called periodic functions because they repeat endlessly in both directions. So what we're going to do now is we are going to make another perfect copy of this, but it's going to start over here and go to the right. Okay? So we're going to need to do some counting here. Everything is going to kind of repeat. Some people like to draw another box. I find that a little tedious, but I'm going to do that for this one, and then I'll show you my preferred shortcut for making this go a lot faster. By the way, this is the tedious part of this work. Once you make your first period, that's kind of where you're thinking and getting things set up. After that, it's just kind of busy work. So I'm going to give you a little shortcut that helps me do this a lot faster. So if you guys will look up here, I know some of you are already filling out the rest of your graph there, but look up here for just a second. If I measure from one feature on a graph to the next time that same feature repeats, when I say feature, I'm talking about something like a max or a min. That should be one period. Right? That is one period. That is the width of one cycle. So t in this case is what? Looks like we're going up by one. So 1, 2, 3, 4. So our period is 4 here. That means that every 4 units I'm going to have another max. So when I do these, I don't draw one. I draw my first period, but then I don't draw my second period and then go over here. I will just go through and draw all of my maxes all at once, because I know they're going to be 4 units apart. So if I start here and I count 4 units to the left, there's going to be another max there. And I do another 4 units to the left, there's going to be another max. And if I kept going, there'd be another one over here. And then I do the same thing with my mins. I've got a min right here. That's going to repeat every 4. Count over 4, boom, here's another one. Count over 4, there'd be another one over here. Go back here and start counting to the left by 4, by 4. Wait, did I do that right? Yeah. 1, 2, 3, 4. 1, 2, 3, 4. So the max and the mins are always going to be 1 period apart, whatever that is. It's not always going to be 4. When we do this one, it's going to end up being 8. And then the x-intercepts are going to happen once every half period. So our period here is 4. Our x-intercepts are happening every 2 units. So I would just go through my x-axis and just draw another point every 2 units. So when I do this, I always draw all of the points first. I'll do all my maxes at one time. I'll do all my mins at one time. I'll do all my x-intercepts at one time. And then once I got all my dots, then it's really simple to just come back and connect them. By the way, when I score these on a test or a quiz, I'm going to be looking for those points and that you have a nice smooth curve connecting them. If your curve leaves the points, like I kind of missed this one a little bit, I'm not taking off a point for that because I can see clearly that your point is in the right place. Okay, so I highly encourage you to draw the points first. All right, what questions do you have before we do the next one? Feeling all right? All right, this one they want us to do a negative cosine. Negative cosine. So I've done this so many times, I know that a negative cosine starts at a minimum, crosses, hits a max, crosses again, and ends at a minimum. So fit that into this little window here. This one's not as tall as the last one we did, but it's wider. And then just do some counting. How far apart are my maxes and mins going to be this time? What's my period? Looks like my period is 8 units long, right? So I'm going to go to this max and I'm going to count over 8. So that's going to send me off the graph. But I could count 8 units this way. And another 8 units this way would go off the graph. I got mins down here. They're going to be every 8 units. So here's one. 8 units to the left of that would be here. And then my x-intercepts are going to happen every half period. If the full period's 8, then we're going to be counting every 4. So 1, 2, 3, 4. I'll get another one there. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. And here is my negative cosine graph. All right. How are we feeling, folks? This would be a great time for questions. We're going to kind of ramp this up a little bit on the next page. You got this, though. Don't worry. So these are our key things right here. Okay, you might need to flip back to this page, but this is going to be one of those things. Once you can sort of internalize what these 4 positive and negative sines and cosines look like, the quicker you can do that, the easier this is going to be for you. So let's flip over and see what we got here. All right, so let me take you through a process. Again, this is a little different from how a lot of people teach this, but see if it works for you. If not, I got other ways that we can go about it too. So let's look at this equation. Can you guys tell me what the amplitude is? There's a super common mistake that a lot of people would make at this point. The correct answer is 3. Anybody want to guess what the super common mistake would be? -3. The amplitude's always positive. The amplitude's always positive. That negative is important, though, because that negative is kind of, I think of that as going with the cosine. That's going to determine which of those 4 forms that we just drew we're going to use. We'll get to that in a minute, though. Can you look at the equation and tell me what omega is? Omega is not 2 pi, it's pi over 2. So omega comes directly from the equation. And then the period we can get by using the formula. So the period is 2 pi times the reciprocal of omega. So flip that fraction over, do a little canceling. Looks like our period is going to be 4. All right, y'all with me? Can you please set your pen or your pencil down at your anchor point? And from there, I want you to go up and down by whatever the amplitude is. And we're going to draw a box right on here. So draw me a box And this is going to be the left edge of our box. I'm going to go up by 3, and I'm going to go down by 3 from that anchor point. And the reason I chose 3 is because that's what our amplitude is. Now I'm going to make the top and the bottom of my box. How wide is my box going to be? 4 units wide. Could you guys please draw me a box that is 4 units wide? And then you can finish up the other side of it. And then I'm going to chop that box up into those 8 smaller boxes like we had on the flip side. So I basically need to cut it down the middle along the x-axis here. And then I need to cut it vertically into 4 separate pieces. In this case, that's pretty easy because 4 divided by 4 is just 1. So here's our little, some of my students like to call this the window pane. One a couple years ago called it the window of pain. I don't know why. He was really good at it. It's like aced it on the test. Apparently it was not fun for him. All right, now this is kind of the hardest part. All we need to do now is throw some dots in here. Where are we going to put those points? It's going to be based off of our trig function. This is a negative cosine. So let's remind ourselves what a negative cosine looks like. Is it going to go through the origin? No, it's not. It's going to start at a max or a min. It's going to start at a min, it's going to come up, and then it's going to come back to a min. So draw some points on there that start down at the bottom, come on up, and then back to a min. And then play the counting game. Start drawing some more points, connect it up with a nice smooth curve. Periods 4, so maxes and min will be every 4. Drawing the points and counting is the tedious part. You guys are going to come up with some other shortcuts to make that easier for you, or at least quicker. If you've got your graphing calculator with you today, please go ahead and get that out. All right. We are going to graph this thing. Now, we want to put our calculator, we want to decide between degree and radian mode. Okay, and when we're graphing, typically we're going to be in radian mode. Okay, there are a few instances where that might change, but typically we're going to be in radian mode. So hit the mode button and check and make sure you're in radian mode. If not, go ahead and fix that. Before we type in our equation, please go to your window setting. And let's make our window kind of match up to this. Now, I noticed that my window on the paper goes from negative to 10 in the x direction. And that matches here. That's kind of our standard zoom window. I'm going to go ahead and just leave the y also going from negative 10 to 10 because, you know, if we were to expand this, it probably would be kind of like that, right? So let's go ahead and go into y equals and type this in. Negative 3 cosine pi over 2 times x. And we'll graph it, and we'll see if it looks like what we got here. Oh, there's one more thing before you graph it. Hang on, sorry, if you've already hit graph, I'll show you this. This doesn't work as well on the older calculators, but try it anyways and see if you like it. Hit second zoom. This is the graph format menu. And a lot of times with these ones, it helps my students to either turn on the grid or grid dot. On the older calculators, like if yours has like the black and white screen, you probably want to do grid dot. That might be your only option. Grid line works better for the backlit color version. When you do that, it's basically just going to actually turn a grid on so that you can more closely match it up to what you're seeing. grid dot, instead of having grids, it's just going to have dots where those grid intersections would be. So grid dot's going to look more like this. You can decide whether that's useful for you or not. For some people, it helps match up. Guys, I'm going to be giving you a lot of handouts with this, which means you're not going to have access to answers in the back of a textbook. My expectation is that you're using your calculators to make sure that your graph is correct. And I'm feeling pretty good about that. That looks pretty much like what I just drew, doesn't it? All right, let's keep going. Let's do another one. Shh. We're going to have to keep moving here, folks. Amplitude. Oh, there's no number in front of this thing. Oh, that's all right. What do you think our amplitude is? 1. This is going to be a pretty, it's not going to be a very tall box when we draw this thing. We're only going to go up and down by 1. Omega, we can see directly from the equation. It's pi over 4. And then the period is going to be 2 pi times the reciprocal of that. Comes out to be 8. Has anybody figured out a shortcut for going from omega to period yet? Yeah, there's a couple different ways. A lot of people will recognize that if it's pi over something, you can just double the denominator and that'll give you the period. Now, if you have something in the top with the pi, that goes out the window. But look for those little things that might make things easier for you. All right, let's draw our box. Now, this is going to be a really wide box, but it's not going to be very tall. Start at your anchor point, go up by 1, down by 1, and then draw me a box that's 8 units wide. And then we'll chop it up into our little window panes. Cut it down the center line, and then I need to cut it into 8 equal little window panes. That's sort of our framework. On that framework, we are going to hang a, what do we got? This is a positive sign. Can you remember what a positive sign looks like? Does it go through the origin? Sign goes through the origin. Does it go up first or down first? It goes up to a max, to the center, down to a min, and then back to the center. So let's draw some points on here. Looking good, looking good. And we'll do a little counting and get the rest of them. Oh, did we find a common mistake already? Can you guys share? Was your issue with your maxes and mins, or was it with your x-intercepts?
I think I put all the points like too close to each other.
Okay. Yeah. So maybe something that I've seen some of my students do before when they're drawing these, and they usually only do it once. They'll actually draw from a max to a max and just label t equals 8. They'll do that once, and then and so that matches up here, and then once you've done that, then that'll keep you from making them too close. That just a suggestion. See if that helps next time. Or maybe now you've made the mistake once, you'll never make it again. So, looking pretty good. I changed my window to go from -6 to 6. That seems to match this a little bit better. All right. So let me ask you guys, when you start doing a bunch of these on an assignment, are you going to be happy when you get a long period, or are you going to be happier when you get a short period? You like the short period? You want to draw lots and lots and lots of dots? Okay, cool. Takes longer. I like the long periods. Question? Why is it double paneled and single paneled? That's a great question. Thank you for asking that. So this is one of the key concepts, is this idea of the period. And the period is, how long does it take before this pattern repeats itself? Okay, so this period, from the equation, from that omega value, we got that this period was 4. So one period has to fit into a window that's 4 units wide. Okay, now this period is 8, which means it's going to be stretched out wider. So in this case, that box, that initial box that I drew, it's got to be 8 units wide. But we're always going to have the same number of kind of panels inside of it. There's always going to be 8 of these things. It's just sometimes they're going to be really skinny and tall like this. Sometimes they'll be shorter and wider. Does that answer your question? Thank you for asking. That is super, super key. Awesome question. Other questions? Yes?
So like on our assignments, if you have, or like if you have a problem like this, how like wide do you need to make that? Like
How wide do you need to go? I'll usually give you one.
Okay.
For most of these, I'll usually be making copies, and I'll give you grids to draw on. Yeah? So x-intercepts are happening every half period, yes. Yes. And the maxes and mins happen every period. You can think about, so no matter which of these we're dealing with, hi, gotcha. No matter which of these 4 we're dealing with, there's always 2 x-intercepts. Well, some of them it looks like there's 3, but that third one kind of just overlaps with the first. So you can think about the x-intercepts happening every 8, really. So like if I'm looking here, or I'm sorry, not every 8, but every period, right? So my period was 4 here. So once I draw this first point, 4 units away, there's going to be another one. And 4 units away, there's going to be another one. It's just that's not my only x-intercept. I'm also going to have to repeat this one every 4. So you can think of it either as every half period or every full period, except there's more than one, then you got to count for. Great questions, guys. Any more before we keep moving? Let's keep it going. Amplitude this time is 3 or negative 3? 3. Omega is pi. That means period is 2 pi times the reciprocal of pi. 2, that's the worst. It's about as bad as it gets. I will not make you graph anything with a period of 1. You'll see why in a minute. 2 is painful enough. All right, so we're going to draw this box now. And the width of it has to be 2 wide. And we got to squeeze all those window panes in there. Now it needs to go up 3 and down 3. But it's only 2 units wide this time. Oops, I didn't go up high enough there, did I? It's only 2 units wide this time, which means when I cut it up into my 8 little tiny window panes, we're going to have some in-betweeners this time. Oh my gosh. Oh, groan. Let me ask you the question again. When you graph these things, do you want a really long period or do you want a really skinny period? We want a long period. This is going to be a lot of points we're going to have to draw. That's okay, though. We got it. This one's a negative sine. Because I'm not a very good artist. Don't judge. Don't judge. I did my best. All right. So negative sine. Does negative sine go through the origin? Yes, it does. Does it go up or down first? Down, and then back up, and then up to a max, and then back down, and oh my goodness. So this is where it's especially useful to just count out your x-intercepts and your maxes and mins. Can you put your phone away, please? Thanks. So my x-intercepts are 1 unit apart here, so I'm just going to go through and just draw a point every unit here to take care of all those. Yeah, you definitely don't want to have to draw like a separate box for every period here. You'd be drawing boxes all day. And then our maxes and mins are happening every period, which is 2 points. So this is kind of halfway in between. So count over 1, 2, 1, 2, 1, 2, 1, 2. back it up. Same thing for my mins, every 2. Yeah, our maxes and mins are kind of in between. They're not on lattice points. You don't like that? I don't either. But that's the way it is sometimes. So what we're gonna hope for when we see these on an assignment is we like the periods that are like 16. Oh, those are the best. All right. That was painful. All right, go ahead and wrap that one up. This next one's pretty important. We're going to have to think outside the box on this one. Guys, we got a lot of side conversations happening. Let's wrap those up here because I don't want you to miss this. Anybody need a moment before we go on to number 8? All right, I'm giving you a moment, and then we're going to move on. Folks, if you've got a couple of periods of this thing drawn, that's fine. You're going to have lots of practice drawing all these points and everything. Like I said, we're going to think outside the box on this one. All right, folks, I'm moving on, and I do not want you to miss this, so please pause on number 7 for right now. You can come back to it later. Let's talk about number 8. Amplitude is our coefficient, which is 1 this time. Omega is pi over 6, which means that our period is 2 pi times the reciprocal of pi over 6, aka 12. Let me give you a strategy for this because 12 does not fit on our graph. We're going to go off the edge. So please do not miss this because we are going to use this directly on Thursday next week when we get into, Friday next week when we get into applications, okay? If we have something that doesn't quite fit, and sometimes this is useful even when it would fit, what I'm going to do is off to the side here, I'm going to go ahead and sketch myself a little window pane with my little 8 boxes in it. Can I get you guys just to make a quick rough sketch off to the side? Let's go ahead and practice getting a positive sign in there. So go ahead and sketch that for me. Sketch that positive sign. Have you done this one already? Okay. And because things kind of don't fit, I'm going to do a little labeling on my box. I'm going to label these vertical lines here where they're going to fall. I know that the first one's at 0. Can you guys put a 0 at the left edge there? Can you tell me where that last one would be if we had a big enough graph to graph it? This would be at 12, which means this one in the middle must be at 6, and this one here would be at 3, and this must be at 9. And once I've got those numbers in there, then I'm comfortable drawing myself a box, but the whole thing's not going to fit in there, right? I know I'm going up by 1 and down by 1, so let's do that. And I know that my box is going to go right off the edge of my graph. And then we'll just use these numbers here to divide it up appropriately. Now, I got one more thing I want you to see here. And I see a lot of people writing, so could I get you to pause for just a moment? This is one of those big connection things, right? What I'm showing you right here is a very algorithmic step-by-step process. That's going to get us started on this, but remember the big idea here is I need you to understand what's going on with this and how this relates to trigonometric functions in a broader context. So see if you can make a connection here. Guys, please don't miss this. There would be another one of these boxes that would be identical just to the left of this, agreed? For that one that's just to the left, where would the left edge of that be? What number would that be at? It would be at, I heard one person say negative. I heard a bunch of people say 12, but it would be at negative 12, wouldn't it?
Yeah.
There would be another box to the left of that. Where would that box start? Negative 24. There would be another one to the left of that. Where would that start? Negative 36. What connection am I trying to get you to make here? What are we doing when we do this that we've already done once in this class back in 4.1? I'm subtracting, each time I'm doing this, I'm subtracting. What's the purpose of subtracting 12? Because 12 is one whole period. It's like the what? It's like the coterminal angles, right? When we found coterminal angles, remember we were spinning around the circle one full revolution. We were adding the same thing or subtracting the same thing over and over, and because trigonometric functions repeat. That's why we were able to do that. And that's the same reason we're able to do this, because this thing is going to repeat every period. Now, in this case, my period is not 2 pi, my period is 12 units. But it's the same idea. It's going to keep repeating. I could add and subtract 12 from this also, so I know at negative 9 I'm going to have another one of those. There's going to be one at negative 6 and at negative 3 and at 0. And if that helps me, then that can help me sometimes if I needed to draw another set of lines here to help me do these last few points. That can help me with this. Okay, go ahead and finish that up. If you've got any questions about what I was just talking about, please ask a good clarifying question here. My hope is that you are making a connection between the fact that these things are repeating every period, that we can add and subtract from our x coordinates by one period and get the same feature on our graph, and that idea of coterminal angles that we talked about back in 4.1. All right. Hey! You guys are going to like this better. You guys are going to like this better, okay? Shh, shh, shh. Stick with me here, folks. This is kind of the biggest example of, remember I said I'm going to withhold some information from you. Just full disclosure, we're going to come back and talk about how there's more going on behind the scenes, but let's look at kind of the simple version of this, okay? And then we're going to expand on it next Wednesday. So here's what we're going to do. We want to write an equation here. We're just going to work backwards. We've got the graph already. We're going to draw the box on the graph, and then that box is going to help us write the equation, okay? So what do we know about our box? We know that our box is anchored at the origin. So put your pencil down at the origin here. Draw me a box that goes up as high as our graph does and down as low as our graph does. We've got the left edge of our box. You guys with me? Look at what's going on here at the left edge of your box, and I want you to ask the question, which of our 4 forms starts at a max on the left edge of our box? Is it positive sine, positive cosine, or negative cosine? Positive cosine looks like this, right? Okay, well, go ahead and start drawing the top of your box out until you see that same feature repeat. We know a positive cosine ends at another max. And it looks like our box is actually going to fill out that whole right-hand side of the graph in this particular case. We don't need to draw all the window panes or anything on here because we got enough information here to get moving. Our amplitude would be the distance from the x-axis up to the top or down to the bottom. In this case, it is 4. Our period is the width of our box. In this case, it is also 4. That's big T. Big G. And then omega is just 2 pi times the reciprocal of that. 2 pi times the reciprocal of 4 would be 2 pi over 4, aka pi over 2. We have all the information that we need. We know it's a positive cosine. We've got our amplitude and we've got our omega. Can you put all that information together and write me an equation? It's going to be positive. You'll have an amplitude. It's going to be a cosine. It's going to have an x in there. Amplitude was 4. Omega was pi over 2. And that's it. If you've got your calculator with you, could you please go into your calculator, set up your axis, set up your window so that it matches this, graph that equation that you just wrote, and see if it matches. We got some questions. Go ahead. Okay. Setting up my window, it goes from -4 to +4. In the x direction and the y direction, it also goes from -4 to +4. Going to y equals, and I think that my equation is 4 cosine pi over 2 x. And I am now feeling very confident that that's correct. Okay, questions, anyone? Mm-hmm. I don't know. So you're asking about a shortcut. If you're going to invent a shortcut, then I guess it's your responsibility to know when you can use it and when you can't. So what I would encourage you to do is experiment. So you've got a shortcut in mind. You know the long way to do it. Okay, so use your shortcut and check and see if it works. And if you work through the 8 or so problems you're going to do tonight and it's working for every single one of them, then I'd feel pretty confident. Okay, but I'm going to leave that up to you. That phone needs to go away. This is the second time I've asked. Put it away. Then go down to the office and bring me a note back if you got an emergency. Okay. So I told you guys you would like this better. Do you like this better? You don't have to draw. It's not as tedious, right? All right. So let's do it. Let's do it again. So I'm drawing the left edge of my box here. It's always going to be right along the y-axis. Not true. That's the part I'm kind of lying about. But for right now, we're going to do it right along the y-axis. And then I need to decide if that's the left edge of my box, is this positive sine, negative sine, positive cosine, or negative cosine? It's going through the origin, which means it's sine to me, and it's going down first, which means it's negative sine. So negative sine starts going down, comes back up, and then it ends right here. Now this is the part that can be a little bit tricky for people at first, is being able to picture where it ends. And that's where you're really just going to have to, as you're spending some time graphing these things, you're going to develop a better sense for that. Okay. You just got to know what these 4 things look like. So once we've got that drawn, we can start finding our amplitude, which looks to be 3 in this case. Oh, I just about got tricked on my period. I thought the period was 2. It's not. Got to look at the scale. Look at that. Look at that trickiness. That's 1. That's 1. So periods, that's rude. That's life. Life's rude sometimes. All right, amplitude's 3. Period's a half. Now, I don't know that I want to use that shortcut with the half. I think I'm just going to go ahead and go 2 pi times the reciprocal of that. That's 4 pi. For omega. And you guys said this was a negative sign, right? Negative sign. So negative something times sine, and then I got an x in here. And it's just a matter of getting the right values in the right place. Amplitude here, omega here, and we're good to go. I would love for you guys to try 13, 14 on your own if you haven't already. And I'll give you a hint. When you get to 14, It's kind of hard to see. I don't see a full period on 14. This is where I might kind of fall back on my little box sketch. I got enough to tell that I know what it's going to do, and I've got some numbers here. This happens at 0, this happens at 3, and I can use that to figure out what the rest of it's going to be. So guys, go ahead and on your own, I'm going to go ahead and put answers up here so you can check, or you can look up here to get a hint. Get my attention if you need some help. I'm sure there's a way you could modify your shortcut to make it work. Yeah. That's the danger of shortcuts. They don't always work. How wide, when you're finding the period, you're asking how wide is that frame? On these, you just have to be familiar enough with what one period looks like so you can spot it. And you're going to get good at that. Okay? One of the things that's going to make you good at that is if you really focus on doing that accurately when you're graphing them. Okay? When we were graphing this, kind of finding those important points, and then noticing, oh, this is kind of that upside down U shape, that's a negative cosine. This one's, oh, that's sort of that S shape and it goes up first, so that's a positive sign. Right? So when you're doing this, that's going to help you get to this. Until then, what you can do is just always start on the y-axis. For right now, they're all going to be on the y-axis. And then ask yourself, how far do I need to go off this direction until that repeats? This is a weird one because the next time it repeat would actually be off the grasp. What I'm noticing happening here is that I've got an x-intercept, but it's a rising x-intercept. That's different from this. But there would be another one over here someplace. And that would dictate the end of my period. Because it's going to repeat. You're going to see that x-intercept with it rising again. That means we're starting a new period at that point. And so it helps me, in this case, it helped me to kind of draw it out and say, okay, well, I'm seeing this part happen. That happens at 3, so then this must be another 3. This must go out to 6. So a period's going to be 6. Questions? I saw some hands. Yeah. Did you get 3 pi? So T is goes to here. So yeah, so t is 1.5, but I'm going to think of that as 3 over 2. And then omega is, oh, you're right. 2 pi times 2 over 3. So 4 pi over 3. My bad. I need to leave my mental math. Okay, folks, let me get your attention. We are wrapping up for the period just in time. We got a few minutes. Your assignment, this is not all of your assignment. I'm also giving you some problems from 4.1 and 4.2 just to keep stuff fresh. So there are some even numbered problems, and it's just a couple. It's like convert radians to degrees, and convert degrees, minutes, seconds to degrees as a decimal, and like draw a reference triangle and do this, because I don't want you guys losing all that hard-fought knowledge before the test. Sometimes we get into, in my first few years teaching this unit, we get into graphing, and people focus so much on that that they forget about all that reference triangle stuff, and then they struggle with it on the test. So there are a few. Canvas has got those. They're even numbered problems. I'll get you answers. Can I just please point out to you that the x scale is different on most of these graphs? Some of them go from -2 to 2. Some of them go from -1 to 1. This one's going from -4 to 4. So make yourself a little note of that now. Shh. My expectation is that you are checking with a grapher. I'll tell you, if I were doing this page, I would probably do all of the problems that had the same scale first, so that I didn't have to mess with my window every time I checked. That would be my little efficiency thing. And then you're going to be graphing some too. Folks, I'll say this too, and I was talking with a couple of you about this. If you are struggling to look at these graphs and find that one period, you're going to get to the point where you're going to look at this and be like, oh, there's my negative cosine. You'll be able to do it really quickly. But I know for some people that takes a little while. If that's difficult for you, my recommendation would be to actually start with the graphing first, because that's going to support that. When you're graphing it, you're actually drawing that period in, and really focus on what that shape of that negative cosine or that positive sine looks like when you're graphing it. Then go back and try writing the equations. I almost wish that I'd set the handout up that way, but maybe next year. Any questions for the greater good before we wrap up here? Yes? Yeah, good question. The 4.1 to 4.3 review, I'm going to check that along with this assignment next class. Okay, so have you all finished at least the odd numbered problems on that 4.1 to 4.3 review? Or you've got a whole bunch of time this weekend? Because if you haven't started that yet, you're looking at probably a solid couple hours of work here. The odds. Oh, those 6 at the end. Good. It's on Canvas. Yep.